Flashing across California desert skies, the airplanes you see here are writing new chapters in the story of man-made flight. There she goes.
This is my first opportunity to greet you as Deputy Administrator of the National Aeronautics and Space Administration. Together, you and I must make our new agency
the most unusual place.
An organization that can challenge conventional wisdom.
We can engineer anything. We can write the requirements for.
We're going to make your idea work. This particular idea is quite disruptive.
A typical flight, of course, starts under the wing of the B-52 mothership.
This sleek, high-speed machine would have made Rube Goldberg proud.
The manner in which we fly re-entry from space on the space shuttle was pioneered on the X-15.
The X-31 pretty much wrote the book on thrust vectoring, along with its sister program, the F-18 HAR.
An observation of an occultation is one of the more challenging missions that Sophia can do.
Right now, we are looking at the dawn of a new era of aviation.
Electrical pulses transmitted with the speed of light.
To help man to see, to control, and to tame the environment of hurtling speed his science has created.
Called telemetry, each craft has its own signature, a unique tone.
Tracking radar is designed to keep one target continuously centered in its beam.
Facilities and equipment for air-to-ground monitoring of test flights were primitive.
When I got here, they had just barely converted from one where the guy sat there, and he actually looked at the airplane and steered that thing by hand.
The radars are accurate to within 3 meters. We know that if the radar is locked onto the airplane, that if we slave the telemetry dish or the LRO to it, that dish will also be right on the airplane.
Flight research results depended mostly on air-to-air chase observations and onboard data recording for later examination.
When I came here, they were taking data from the airplanes on these oscilloscopes. We had to read the times off of ticks on the film. Now there's onboard computers that uplink and downlink.
Real-time data rather than coming down and analyzing data between flights.
Large computational problems are resolved in real time as opposed to waiting till the data gets down.
Radar coverage is limited to line of sight and is unable to see over the horizon or behind mountainous terrain.
Before the X-15, all of that coverage could be accomplished from a single location. The X-15 didn't allow that because it had to extend much farther away from the base.
Dryden engineers developed a complex system for flight monitoring that went far beyond anything yet known. The range allowed researchers on the ground to track the X-15 throughout its entire mission.
My experience with the implementation and operation of the high range was in line with the extension of flight profile from some few hundred miles to circling the Earth.
A hypersonic research vehicle or a transatmospheric research vehicle. You are going to be completely dependent on the range for a successful mission.
The Western Aeronautical Test Range of today is the high range grown up. A functioning integration of state-of-the-art communications, tracking equipment, computers, and electronic display systems.
Every critical function of the X-29 is monitored from the ground.
We actually collect on the order of 250 to 300 pieces of data telemetered to the ground.
AFTI's total dependence on computers and enormous data output require a great deal of range support. The shuttle's safe return depends heavily on the range's precision operation monitoring the spaceplane during its return to Earth. Pilots fly remotely piloted research vehicles from cockpits on the ground, depending completely on telemetry provided by the range to receive sensory information from and send commands to the airplane.
The key to a successful research mission is uninterrupted communications and data links with test vehicles.
The capability that we have here is probably better than any existing capability anywhere in the country.
We have radar, we have telemetry, video, communications, flight termination, long-range optics, ramp cameras. We've supported everything from the X-1 all the way up to modern projects.